I just built this AI automation to create long-form YouTube content. In a previous video, we had discussed how to create short-form content, POV history videos for Reels, TikTok, and Shorts. Using this one, you can create long-form videos. I've tested creating up to 6-minute videos. Of course, you can create even longer. That requires more memory and more resources. Here is an example.
From the moment Alexander was born in 356 BC in the ancient city of Pella, Macedonia, it was clear that destiny had something extraordinary in store for this young boy. Son of King Philip and Queen Olympias, Alexander was raised amid the...
So I'm obviously not going to go through the whole of the video, but you get the idea, and you can create children's videos,
Imagine chasing a glowing butterfly through a vast garden.
motivational video.
Imagine a vast land stretching in every direction. No roads, no signposts, no maps to guide you. This is the realm of truth. As one philosopher suggested, a pathless land. We often believe truth is something to...
So there are plenty of use cases for this. The idea is to create automated faceless videos that you can post regularly, hourly, or daily to your YouTube channel. There are plenty of channels. There are more examples here. For example, this guy.
It was a normal day at school. I went to an
Horror
just named him
stories,
Luke for this story.
motivational videos here, like this guy here. Book summaries. This guy just have 15 videos and already have like 1.6 million subscribers. So that's the idea. Create automated faceless videos. So this agent here creates the video ideas and also converts these video ideas into videos. The story itself is told through images. So that's the idea. Here's the part that creates the video ideas. And then we create the story, audio generation and transcription, and then we cut the videos. You may have noticed that these videos are cut to the audio. They don't stay on the screen for 5 seconds, and then there's a pause, and then next 5 seconds the images are only shown on the screen for the duration of the spoken words. So that's this scene cuts. It cuts the scenes, and then it generates the image prompts for each scene. Then we are using Fal AI, and then afterwards I also have a workflow here using GPT, the new 4.0 image generation. I'm not using it, but it's a bit more expensive at scale. Also, I'm using OpenAI's audio generation model, GPT 4.0 Mini TTS. You can use 11 Labs if you want. You can borrow the code from one of my other workflows on school. By the way, this is our school community. All the courses and everything as a new community, but we have a few in n8n agent builds, AI scraping course. We have different n8n agent builds, short form video, SEO workflows, etc. So check it out. All the prompts for this video also will be in the school community. So that's the idea of this workflow. Once the video is generated, it will get uploaded to a Google Drive like this. It also publishes the videos to YouTube. For example, here's a published video here.
In a bustling school filled with chatter and laughter, one child...
We are also not using JSON to video or Creatomate or any third-party API to assemble the video. I am providing here a code node which does most of the work and also adds caption to the videos. If you want to make any changes, you just simply copy paste the code to ChatGPT and ask it to change a certain element and paste it back to the code node. If it's a long video, if you don't have enough memory on your n8n server, this might fail. So in that case, I also have a HTTP point which you can use it for free. It will be in our community, or you can download the code and host it yourself and use it the same way that you would use JSON to video or Creatomate API. It's not as sophisticated with a lot of templates, etc. It's just one template now. But then again, if you want a different style, ask ChatGPT to change the code and add a little bit more transitions if you want to change the caption, etc. So that's the idea there. So let's go through the workflow a bit more in detail. The first part is to generate video ideas for your videos. It's pretty simple. This is n8n, a no-code platform. This is what we are going to use. If that wasn't clear already. And this portion here generates the video ideas. I'll walk you through it. You don't have to be that technical to understand it. It's pretty much drag and drop. Besides, if you go to our community, you can download the whole thing by going to workflow.json and downloading this. Download that, and now you import from file and select that downloaded file, and it will be loaded. And I will now walk you through each of the steps. So this one here is generating video ideas. Let me enable that first node here. These are what are called as nodes. The first one node here is the schedule node here, which means that the process runs periodically. In our case, every 1 day. Interval is day days between triggers is 1. That means that every 1 day at midnight, you can set it to whatever. You can manually run this as well by clicking on test workflow here. I usually do the manual portion for this generating video ideas. And we have another node, which is the set node here. We have a few variables to set. We define the niche, the topics, and how many ideas to be generated. So for example, here I might say something like, I want a motivational niche or self-improvement niche, motivation and topics, meditation, philosophy, etc. Now I can run that part. So if I disconnect that and run this workflow here, you can see that we have motivation, meditation, philosophy, and count coming out of it. So the next agent is, if you click on the plus there, that is the AI agent here, which just means that it is able to connect to a large language model like OpenAI in our case. So once you do that, this won't be there. So you need to click on chat model and say OpenAI chat model or any of the LLM that you want to specifically use. In our case, we are using OpenAI chat model and we are using GPT 4.1 mini. We are also setting the response format to JSON here, and we are using one tool. So the agent means that it can run tools. We're connecting a think tool to make it smarter. This basically is an n8n node for a tool that will turn these non-reasoning models into sort of a reasoning model, but not quite, but it invites the agent to do a little bit of chain of thought prompting. You don't need to know what that is, but if you understand it, that is great. It just means that it allows the agent to think for a little bit before producing the output. That's the purpose of the think tool. This is a very new tool, n8n, hardly a month old. So if you want to use this, you might need to have the latest n8n installation. So the prompts, again, we are defining a prompt user message here, and this prompt is basically defined in ideation agent, which is this: create story ideas for long-form YouTube content for 2 minutes. And let's examine that. If you are building from scratch, just copy this and paste it into your workflow. Let's expand that. That will show you how these variables are replaced. These are coming from, again, from our node, from the node before. Create story ideas for long form YouTube content around 2 minutes for motivation YouTube channel about meditation, philosophy, etc. Using the think tool to think. If you don't say that, you wouldn't use the think tool. Sometimes you have to explicitly tell the agent to use the tool, otherwise it won't work. Tools and output in JSON in this format, specifically ideas. It will have category, story idea, duration, tone, and format. That's basically it. Let's run that. Let's test that. So that's the output that you can see that in JSON. It's a big JSON string, but it's not quite in the format that we want. You can use the require specific output format and add an output parser to it, but I prefer setting the response format to JSON and using a set node, because more often than not, I get errors using the structured output parser. Maybe I'm doing something wrong, but it sometimes say something like the model didn't provide the specified schema. Especially when you're using cheaper models, there might be a mismatch, and then that leads to an error. This one, using the response format JSON, is built into OpenAI API, so it's much more accurate. And then after that, we are using the set node to convert this string JSON into an object JSON. You test that. I should have pinned that. Stop. I'm going to pin it this time so that it doesn't get executed again. So now you can see that the string JSON is actually nicely structured ideas. You have 10 ideas in there. And the next, we need to insert this into a Google Sheet. This is our ideas sheet. It's a Google Sheet, and want the ideas to be added from the 81st line onwards. Let me just delete that. And now for that, right now we are getting everything in one item. So we want it to be split into 10 items so that it can be written to the Google Sheet one by one. So that's why we are using the next node, which is called a split node. This is the split out node, and I've only renamed it into split ideas, and all our ideas are in the output ideas position, that field over there. So that's why we have to drag and drop that here. So we want the ideas inside that object to be split. So if I spin that and spin that too, so it won't get executed. Test this step. then now we have 10 items. Here in the input, 1 item, that's been converted into 10 items. The next node is a Google Sheet node right here. And then we want to append rows in Sheet. That's that node here. So all the 10 items that is coming from the previous node, we want it to be written to that Google Sheet. You need to connect your Google account to this. In order to do that, you need to do a create new credentials, and you have to pass in the client ID and client secret. This client ID and client secret needs to be taken from your Google Cloud Console, which is this thing here. You need to actually create a client and use the ID of that client. This is for authentication purposes. You simply create credentials here and create a new client ID, auth client ID, and then go through the process and get the client ID. To get to this page, let you know very quickly, it's just cloud.google.com, and then you go through the processes and create a new client, select the client ID and put that in there, and the client secret. Once you go inside the client, you will see the client secret and copy that. Once you click on this, copy that and paste it there, and yeah, that's how you add the credentials for Google Sheets there. Once that is done, you select sheet within a document from resource, and operation is appending row. We need to append these incoming records at the end of the document, that is append row. And long form videos, once you have your account connected, when you click on this, it will load all your sheets that is available in your account. We want the long form videos, this sheet, the name of this sheet, and we want to write into the ideas worksheet over there, that is the sheet input over there. And I'm just going to select map automatically because our headers match category, story, idea, duration, tone, and format. Those names are the same: category, story, idea, duration, tone, and format. So I'm just going to test that step, which means that this will execute that just one node. Now we were at 81st. Now we have meditation, explore the power of mindfulness, stuff like that. And we have 10 more ideas. Explore the stoic practice of negative visualization. Let's take that idea, and we need that to be video generation. So that is the status column here. If you want to, there's a status column over there. We have to set the status to video generation for it to be picked up in our next segment. So that's the idea generation part of it. And next, we will have a look at the actual creation of the video and publishing to YouTube. It starts with the schedule trigger. You can set it to whenever you want it to run. And the next one is reading from Google Sheets. We want to read the rows with the status video generation and get only the first matching row. For that, we use a Google Sheet node, Google Sheet, and you select get rows in a sheet. And in that, we use the same Google Sheets account. Resources sheet within a document, operation get rows. Select the document and the worksheet inside it, the ideas worksheet, where we will read from. And we are only interested in the rows with the status set as video generation. Let me just run that. And now you must get that negative visualization, explore the stoic practice of negative visualization and its effect on resilience and motivation. So we have that one record. Let me just pin it and connect it to the next AI agent, which is again a AI agent here. Let's call it a story agent. And we have a system prompt here. In that, we are saying, I'm not going to read the whole thing, but you can get this prompt again from our community here under story agent. Let me just quickly cover the main points. You're a YouTube scriptwriter, write an engaging story, category, duration. We are telling it to take it from the input. And dialogue rules, if it's like a dialogue between characters, then don't narrate. That is this section. Just add the dialogue. And we are connecting it to, again, GPT 4.1 mini. You can experiment with the different models. Response format, text. And we are also adding a think tool to it to enable a little bit of chain of thought prompting. And let's test it. And you can see that it will use a think tool. Stoic practice of negative visualization is imagining the loss of things we cherish. So that is complete now. Let's examine the output of it. We have an output here. Imagine walking every morning. That's the storyline. And remember, this is based on the duration that we give. So for example, in this record that we read from Google Sheets, the duration is set to be 2 minutes. If you give 20 minutes, for example, if you change the duration here to 20 minutes, it will be much longer video and take much longer to create the video. So if I go back to our workflow and pin this, and let's disconnect it and say test workflow. So now it should create a much longer script. It must be about 20 minutes. But again, so that is, I'm just demonstrating that let's revert it back to maybe 1 minute for our purposes. Video generation, and let's do that again. Pin that and pin that. And now we are converting the script into a audio form. You can use 11 Labs for this. For simplicity's sakes, I'm using OpenAI's generate audio option. This is simply, if you click here, audio, OpenAI. So that's that node over there. And you select your OpenAI account, resources audio, and then you give the model name as GPT-4 or mini TTS. This is a new model. So next, for that reason, n8n won't recognize it. So make sure you select the expression here. So if you change to fixed, it will have only TTS1 and TTS1 HT. Change it to expression, and the input receives the value of the output from story agent, which is basically the actual story that needs to be narrated. Or if it is a dialogue, the voice will be the same for every character. We have these many voices available here. 11 Labs have much more. Let's run that. Let's disable this and test workflow. So that's the audio that's been generated, and you can listen to it.
Imagine waking up one morning, overwhelmed by the fear of losing everything you cherish, your health, your
So that's the audio. The next node may or may not be necessary. Sometimes when OpenAI comes back, it lacks the audio MP3, the file name in there. So the next node, we are trying to transcribe this audio generator to get the timings. If the file name is not there, that will fail. But looks like this is actually producing a file name. I'm adding it as a fallback. What it does is, if the output from the previous node doesn't give you a file name, it just simply adds a file name, audio, and gives a date in the file name as well, and tries to create it. I'm going to pin this thing. I'm going to run the next one. Okay, we can't. We can't really pin binary data. Then we run this thing again. So now we have the file name changed. You may not need this because, as I said, the file name is already available. Sometimes it doesn't have it. I don't know why, but probably a bug with OpenAI. The next one, oh, we actually accidentally kicked it all off. And the next one is transcribing this audio into word-by-word transcript. So the transcribe with segments node is an HTTP request node again. And the method is post. That is the URL that you have to use for transcriptions, audio transcriptions. It's basically Whisper behind. And predefined credential type, use your OpenAI account. You can use the same OpenAI account here. Enable send body, parameter type, form data. Model is Whisper1, and response format is verbose JSON. We are providing the n8n binary file from the previous step, which is the audio that we just generated. And this is very important, timestamp granularities. If you don't give this one, it won't produce the word-by-word transcript. It will be just much broader. It will still be in segments, but it will be not this granular. If you give timestamp granularities and add word, then you'll get word by word timings, the start and seconds in the audio timeline, which is very important. So we have this text. Imagine waking up one morning overwhelmed by the fear of, which is basically what we use to generate the audio. Imagine that's appearing at the start, and this is at 0.5 seconds, and that's at that many seconds. This is useful when creating captions, and also this will be used to create scenes. That's why it's valuable. All right, let's get into the scene generation part of it. So the first portion, you have two agents here. The first one is actually cutting the transcript into separate scenes. This agent here, named cut agent, it will cut the transcript into appropriate segments to effectively tell the story. Prompt is very simple. You're an excellent scene editor. Have a look at the story, word by word story, and cut them into 2 to 5 second scenes. Produce the JSON output with scenes, scene words. Pick these words for this duration from the word by word transcript. Word by word transcript is that, really. So JSON words, I'm simply dragging and dropping this. And if you simply do that, it will be just object. So you have to do two JSON string. Then it will be word, imagine, and it will have all the timings, start time and end time for that particular word in the audio timeline. Let's run that. So once that is run, you will have something like scenes, this big array here of different scenes. Because I will run that already, it goes to the parse node, which is again a set node here. I've simply named it as parse, which is basically dragging and dropping this JSON output and converting that into an object. Again, I have given the model response format as JSON and selected 4.1 mini as the model. So as a result of that, in that set node, we will get multiple scenes. The agent will cut the transcript into scenes in the best way it can to effectively tell the story. For example, that is first scene. Imagine waking up one morning overwhelmed by the fear of losing everything. But if you give a better model, it may do a better job. So it will try to find the right way to tell the story, not to dwell in the past, and the strength to keep moving forward. So we'll see how this works out when you actually see the video for this. And moving on to the next AI agent, this is direct the scenes of the story and create scene image prompts. So for each scene, we are trying to create an image for each scene that the previous cut agent has produced. And in this AI agent, which is the next node, again, AI agent with tools, we will be passing the parsed scenes. And you have a system message here, which is a long message, but we are not going to read the whole thing. But the main points are analyze the scenes and determine what visual elements need to appear. Use a variety of cinematic shots, establishing action, wide, close-up, POV, etc. And if the transcript contains just dialogue, create appropriate characters to speak the dialogue. Each scene must have these keys in the JSON output, text on screen, from segments, scene, image generation prompt. That's where the generation prompt will be created. So maybe it will make more sense if I show the output first. Let's test that. We can't pin this split out. No, I unpinned the wrong thing. So you can see that is thinking through and creating the character profiles, determining that's the image generation part as well. I will let that run too before stopping it. Okay, so what happened here? So you have the scenes there. We should have, again, we are parsing the string scenes into an object using the set node. And in here, you can see that the output has multiple outputs. We are adding a seed image generation prompt shot, early morning bedroom with soft natural light filtering through the window. We have different shots here for each scene, and these image prompts will be passed onto an image generator. In our case, we are using Fal AI, which is this service over here. It's pretty fast in generating images, and it is the same pricing as Replicate or something similar. I have added $10 to it, and since I've been testing, I've spent that much only. But I'm mainly using the Schnell model, which is the Flex Schnell model here, and it's pretty cheap. It's 0.003 dollars per megapixel. So that's how much that costs for 1 megapixel of image generation. So that's the scene cut and scene generation, image prompt generation part. Let's just pin all that and move on to the next section. So let's have a look at the image generation now. So far we have created the scenes and image prompts that we need like that. For each scenes we have a shot, early morning bedroom with soft natural light filtering through a window. We are using a service called Fal. This is an HTTP request node, this node here. So this is the endpoint for Fal AI to create an image from the prompt that we give. This is for the Flux Schnell model, as you can see here, and scene image generation prompt. And that is passed to you'll have to enable send body and body content type JSON. And in the prompt, we are passing in the scene image generation prompt. You'll have to provide the authentication parameters for Fal AI. For that, simply create a new credentials and create an X API key credential. And after signing up for your Fal account, which is Fal AI here, you will go to API keys here, add key, and that will give you an API key. Just paste that API key into your authentication headers. That is pretty much it for authentication. And image size is landscape 69. That is suitable for long form YouTube video content. And once you run that, it will go into a queue. You won't get the image just yet. You'll have to wait for a bit. That is why we have a wait node as the next node in here. I'm giving 10 seconds. It doesn't require 10 seconds. Probably like 5 seconds for each image. And after that, you need to check the status of the images. For that, you will get a status URL from when you issue a request to Fal here. So you will have to make a request to that URL using another HTTP node. And that's what we are passing it here. Make sure you enable expression here whenever you drag and drop. It will get enabled when you drag and drop, but sometimes you can click on things and people wonder if I change that by mistake, it won't work. So make sure that is expression and that's in green. Simply, that's just me dragging and dropping the URL there. once you send a request to that endpoint, you'll have to use the same file authorization credentials. Nothing else needs changing. This will be a GET request, whereas the previous node was a POST request. And you will listen for this status here. Only when the status is completed, then only you will have the image. And we are checking if the status is completed using an if node, which is basically an if node here. Route items to different branches, true, false. And the if node, we are checking the status, JSON status, and checking whether that is completed. If it is completed, we proceed to the next node to get the images generated by the AI. If not, we go back to the wait step here. That's what's happening here. And in the node, this is again an HTTP request node. I've just renamed it to get images. And in that, we are going to pass this URL, flux request, and then the request ID from here. That is the response URL you see here. And the method will be get. When you send a request to that, you get a response like this. You will have an images array, which will have the image. So that's the image. This is a set node that I'm just using to pull the information from the previous nodes and make it available here. You can reference to other nodes directly as well, but I want the images there, text on screen from segments, duration on screen, etc., and the transcript from an earlier node to be pulled into the front of the current node execution. You don't necessarily require that, but it's just something that I do for, I don't want to refer back to 10 nodes before to get those items. I can just refer from here. That's the idea. You can skip this stuff if you want, if you know what you're doing. And after that, that's the image generation part. So we have 16 images generated for this storyline. And now we have to combine all these images and make a video out of it. To create the video, we need to prepare the data. So we need the images, the transcript, and the audio file. The audio we have already created at the beginning of the workflow here. And we're just converting it. So the audio is like this, in binary format that we can listen to, and that will be converted into something called as a base 64 image format, which can be compressed and sent across the wire, across the network to your API or the code. So we have to take this from all these different pathways. So we are using the merge node here. Simply add a merge node. That's how it works. And we have to take input from 4 different pathways. So that's why our mode is combined by position, and number of inputs 4. We are connecting all these paths. So from this path, we will get all the images. From this path, we will get all the scenes. From here, you get all the transcribed segments. And from here, we get the audio. And we combine everything, and we have 16 items as part of the 16 different images created. We want to send one single request to the code that, or the API that creates the video, that we need to convert these 16 items into one single request. So that's what this here does. 16 items, and when it comes out of the aggregate node here, it comes out as one item. So it is the aggregate node. Aggregate, the mode is all data items that are coming from the previous nodes. Put it into a single field called segments and include all fields. So the output will look like segments, and it will have multiple segments to the story. You should have 16 segments because we have 16 images. So I should stop at 15. So 0 to 15, that's 16 images. And in each of these segments, we'll have one image, and it will have what to show on the screen when the caption is being generated. This was added during testing. You don't really need that. And the word by word transcript as well. So what will happen in the video generation process is that this text will get matched to the number of words in the transcript, and the image will be cut to that duration. The video generation process will know where the word everything ends, and it will cut there. That's everything, and it will cut around about 4 seconds. There's no static duration for the images. And let's have a look at our video generation, how that works. We have a code node here. This is the code, about 700 lines of code, which does exactly what I just said. It is a little bit complicated. If you import the JSON, it will already be there. If you're building from scratch, just copy this from our community. I will go through this path first. Let me delete this and show you the code. The code will create a command called ffmpeg command. ffmpeg is a tool to create videos, or it's a demixer. It can convert between video formats. It can separate audios from video, and it's a very powerful tool which can edit videos for this to work in your self-hosted environment, you will need to do a few things. You will need to install FFmpeg on your n8n instance. For me, I run n8n on Railway and Hetzner. For the purposes of this video, I have this on Railway. If you had installed n8n from a Docker container without any additional Docker file directly from Docker Hub, you can run this command here to install FFmpeg on your Docker container that runs n8n. But if you do this way, every time Docker container restarts, you will lose the install when the container gets redeployed. The easier fix for that is to add this command, apk add no cache command, in the Docker file itself. So if you're using something like Railway, you can use the Railway CLI to interact with the Railway container, which is brew install Railway if you are using Homebrew on macOS. Once the Railway CLI is installed, first you'll need to Railway link. That will link that project. So that will be n8n, and select the worker, and then Railway SSH, which will connect to the worker node of n8n, and then execute that command to install FFmpeg, apk add no cache. That will install FFmpeg there. Now we can execute the command. So this one simply generates the FFmpeg command to be executed. So I'm executing the rest of the segment here. That's created the FFmpeg command. It is executing it, and it will then read the files created by the command from wherever your n8n is hosted using a read-write node. I will wait for it to complete, and then I will explain it. The FFmpeg code node that generates the FFmpeg command, as I said, and then in the output it gives a FFmpeg processing details. These are, you don't need to really worry about that, because if you don't have a lot of memory, the FFmpeg command will fail on your n8n machine, so you need to do it in segments. The rendering, that's why the code is a little bit long. I was doing with a single, much simpler code, but then it was running out of memory, so I had to do some adjustments to make it work on machines with a smaller number of CPUs. You'll get a command in sequence here, which is a list of commands that need to be executed. And this will be passed to the execute node, and that node will actually execute the command. So this is just command creation. So the next is a execute node. Again, for this code node to work, you also need this environment variable to be set, node function allow built-in, and you'll have to add this fs path os crypto url https. If you don't want to meddle with any of this, just use the code from our community. But then again, you'll have to host it as a separate API using Railway or something like that. If you're not self-hosting, this won't be possible, because you can't really change the environment variables on n8n cloud. Just to let you know how it would look like on your hosting provider, you will have variables. So that will look like node function hello built-in fs path crypto. You don't really need the child process. You can ignore that. So that's what that was. And then the execute node, all we are doing is we are taking the commands and sequence property from the previous node, which the code node outputs is this command here. So you can see it's a long command that is generated. Once that is executed, what it does is it creates a bunch of files, directories on your n8n hosted account. So make sure you have the right permissions. It creates everything in the temp directory. So make sure n8n process has access to the temporary directory, which is /tmp, FFmpeg processing details. So the images are stored in TMP. Each execution gets its own directory. This is on the n8n hosted machine. So make sure TMP, you have access to TMP directory. If you run into problems, just let me know in the comments and I will reply to you. The last node is so after executing FFmpeg command, it would have created a video, and that would be stored on n8n server. Then we need to get it from the server. So that's what we are doing here. This is just a read-write files from disk node. I had hard-coded this for some reason. So in the file selector, what you would need is from the FFmpeg generate command, you will have the FFmpeg processing details. Come back here and final video output path. We have to drag and drop there and to read from that file. That's what we have to do there. I've pinned everything before, and then maybe I can just test it from here. I should have disabled that wait node. Once that is finished, it will come here. Now it is reading from the disk, and you should be able to get the final video about the stoic principle of negative visualization. View.
Imagine waking up one morning, overwhelmed by the fear of losing everything you cherish, your health, your job, your loved ones. It's a heavy weight, isn't it? What if this fear could become your greatest strength? This is the essence of a Stoic practice called negative visualization. Ancient philosophers taught that by consciously imagining the loss of things, we're reducing its power over us. When you
So you can see that it is cut to the audio. It has that zoom pan effect. If you want to change the way it appears, you can just copy this the whole command and ask ChatGPT, can you add an X-fade transition in this n8n code node, something like that. Then you give that and it will give you the code, and you copy paste that code back into the node. That is pretty much it. We will explore the next branch here by hosting it as an API, as a separate service. We'll look at uploading it to a Google Drive. You can add this Google Drive here as well. If you don't want to affect your n8n host installation at all, you can use this HTTP API node, and you can host the code as an API endpoint. Similar to what you would do with JSON to API or Create-O-Mate, you have the code in this repository, GitHub repository called, that's the URL, video API. All the URLs, everything will be in the description. You'll have to fork it or download it to your computer. It has a Docker file. All you have to do is, if you have something like Railway, you create a new service from GitHub repo, and then you give that repo ID. And then if you do that, it will create a new service. Similar things will be possible with DigitalOcean or any other provider, but you can create apps from GitHub repository. And so once that is done, you deploy that. If you deploy that, the deployment is complete and it says active. In order to access it, you'll have to create a temporary domain for it. When you come here to settings, I will generate a domain. You can do the same thing with your own hosting provider, similar functionality. And if I click on that, you'll get, that means it's running. And then copy that, come to our workflow and replace the first bit of it with this one. Actually, we need the HTTPS, and there you go. So now it is pointing to that hosted service. So for clone from GitHub and go to your hosting provider and choose the deploy from GitHub option, and it should automatically detect that Docker file and everything that we have. I have a Docker Compose and a Docker file, whichever you want to use. So all this is doing is similar to the code node. We are taking everything from the edit fields node before, which prepares the data. It's the same kind of request that will be passed to the API as well. So you can see all the segments, and the audio is passed in, and the transcript. 3 main pieces there. And the segments have images and the text on screen, what needs to be shown on the screen. Let me run the whole thing and I'll explain the nodes one by one. Now it's getting executed. And if we go to our deployment and see the logs, there you go. It is generating the video. Yeah. Using CPU capabilities. If you have a GPU, it will be much faster. I have a long videos folder here. It should get uploaded here. It's not the one. Yeah, it's uploading it to Google Drive now. I should see the new one very soon. Now it's creating the YouTube upload link, and it's uploaded to YouTube. That was very fast. So we should see that in here, Stoic practice of, I think that's the one. And it is uploaded into our Google Drive. So what happened here? This is simply taking the request from the previous node and sending it to that API. And then the output of that is the video, the generated video. So this is a method post request to that URL of the API that you just deployed, and using send body enable JSON, using JSON, is sending the JSON. So that will look like the whole thing. And in the response, this won't be available in the beginning. So you have to add it from add option and then choose optimize response, and then select response format is file and put the output in data. And that is how you do it. And after that, this will upload it into a Google Drive. This is simply a Google Drive node. Create a new credential for Google Drive account. Similar thing that we did to Google Sheets client. We can use the same client and client secret here. Once that is done, you choose the operation as upload, resource is a file, and data is coming from the input data field name, which is the data field, which is the binary field here. That is the name of where the data exists, which is the data attribute. That's here. And the file name is, we are taking the raw number from the Google Sheets, which will be 88, and taking the story idea. So 88, that is the one that we had set for status is now published, and it takes that 88 raw number and takes the first few 10 or 15 characters of this idea, and that's that explore the story practice of, and you attach the MP4 extension at the end. And parent drive, my drive, you select the drive, and then you select the folder, which is our long videos folder after creating the folder in your Google Drive. That's pretty much it, and that's how it gets uploaded. And in this path, you need to first create a YouTube link, and then we need to stream the output, the file, into that link to finish the upload. So first we create a container. It's called as a container in YouTube API terms, which is basically, it will give you a URL where you can stream the data to, the video data to. So just follow this node, and that is the URL that you have to use to upload. So it will give you, this one actually won't upload the URL. Again, it will create a container where you can stream your data. Post method, take the YouTube or the API credential type. In YouTube account, the similar way, create credentials, same client ID and client secret can be used for authentication, and select YouTube or OAuth2 API. And after that, send headers. Content type is application JSON. Upload content type is video / webm, and send body content type is raw. Content type is raw JSON, and in there you have the title and description that you will use for the YouTube video. You can add other things like tags, categories. I think 24 is like lifestyle and entertainment. You can get this by asking ChatGPT what is the category ID. And private, if you set it to public, it will be public straight away. You won't have a chance to review it, it will be published. So that's that. And made for kids, etc. Similar to what you would put on a YouTube interface when you actually manually upload the video. And that will give you the location where you can stream your data to. So we also need the data from the actual video also. That's why the merge node exists, and we are collecting the data from the video. The reason we cannot directly connect to YouTube upload is because this node expects the video to exist in the previous node. In this case, if you do that, the previous node will be the create YouTube upload link, which won't have the video itself. So we are using a merge node to circumvent that, and now it will have the video in the previous node, and also it will have the link location. So that will be the location that is created in the create video upload link node, JSON headers location. And we are streaming into that URL, which will be using a put method, and same credential type, YouTube or the API, YouTube account, and content type video webm, send body. And here you select n8n binary file, and then select the attribute field name where the binary data sits, which in our case is data here. So that's that. Once that executes, that will be uploaded to YouTube. And let's see the status of, I think it's done.
One morning, overwhelmed by the fear of
So that is said, we have a 1-minute video here. You can change the duration by changing the duration in the sheet, but test it out depending on your n8n hosts, n8n server's capacity. You might be able to do up to 30 minutes to 1 hour. It'll take a while though, but you can also write your own story here and to use it as a seed story, and then the AI agent will put together the actual story and create the final video. And finally, we have a Google Sheet node again. With this, we used to update the published status. In this account, we're using the same Google Sheets account, resource, sheet within document, update row, operation, form videos. That's the document that we are using, and the ideas worksheet, again, this worksheet here. And in that, we are using the raw number to match, which we selected from Google Sheets item JSON raw number. This is coming from the previous node here, Google Sheets raw number. And in the status, we are setting it as published. So when you select map each column manually, all the columns will load here automatically. So that's the whole workflow. All the links, everything is in the description. Check out the school community. We have a lot of cool automations here, still adding more automation. We do have discussions there in n8n agent builds. For this code, it will be under Faceless video storytelling. And we have POV history videos, social media agent, Reels repurposing agent, and keyword research agent. This is for SEO. And we have a 3-in-1 lead generation called outreach. So it sends personalized outreach emails, and you have a SEO long form article generator. So that is it. Check it out. Pretty new community, but it's growing. We also have AI scraping and also information model context protocol. Nothing much yet, but I am adding more and more there. So that's it. Be sure to check out the links if you want this template, or feel free to replicate by following this video. I'll see you in the next one.